Hey everyone, welcome back to the channel Code with AKJ. Today is day 24 of solving LeetCode 75 challenge, and today we are gonna solve new set of questions from a new topic, that is stack. So if you are new here, don't forget to like, share and subscribe for daily coding problem solutions. So today's question is removing stars from a string. So we are gonna solve this question from brute force solution till optimal approaches. So let's get started. So the question says you are given a string S which contains stars. In one operation, you can choose a star in S, remove the closest non-star character to its left, as well as remove the star itself. And finally, return the string after all stars have been removed. So we have given two notes. The input will be generated such that the operation is always possible, and it can be shown that the resulting string will always be unique. So the problem says you are given a string S containing lowercase English letters and a star. So generally star removes the closest non-star character to its left along with itself. So our goal is to return the final string after all the stars are removed. So given example 1 here, LeetCode. So this particular string has 3 stars. So we need to remove all the stars along with its leftmost non-character. So if we try to check the first star, the leftmost non-character to this particular star is T. So we'll remove the star itself and the character here. So the string becomes LEE star COD star E. So after performing the first operation, our string contains these values. So again, after checking this particular star and removing the leftmost non-character, that is E here, along with the star itself, we'll get the string as LECOD star E. And finally, the last operation, that is the last star. So after removing it, we finally get the string LECOE. Since there are no more stars here, so we'll return this particular resultant string, that is LECOE. Same goes with the second example here, that is arrays along with 5 stars. So since the non-characters here are 5 and the number of stars are also 5, we'll get a empty string. So we'll return empty string in this case. So this was all about the problem statement. So let's get started with our brute force approach. So in our brute force approach, a naive way is to iterate through the string, and whenever we encounter a star, we'll remove it along with the closest preceding character. For example, in this given string, we'll start iterating from the front, and if we find a star character, we'll find its index in this given string. So after finding it, we'll remove the star as well as the non-star character. So in our first operation, after removing this given star and T, the string becomes LEE star COD star E. And again we'll find the index of the first star from this given string, which is this particular star, and then we'll perform the operation by removing this and the preceding character, that is E. So after performing second operation, the string becomes LECOD star E. And again we'll find a star in this given string, so we'll find the index of it. So we found the star at this particular index I, and we'll again perform the operation, that is by removing the star along with its preceding non-star character, which is D here. So we'll remove these two characters. So our string becomes LECOE. So again we'll check whether this given string has stars or not. So since there are no stars in this given string, we'll return this resultant string in this given example. So this was the first example. So let's quickly check our second example as well. So again we'll iterate from the start. We'll find the star with its index. So the first star is found at this particular index. So we'll perform the operation, that is removing of the star along with its preceding character. So after performing first operation, the string becomes ERAS along with 4 stars. Again we'll find the star with its index. So we found at this particular index, and we'll remove this star along with its preceding character. Then our string becomes ERA along with 3 stars. So again we'll find the index of the first star in this given string. We found at this particular index. We'll remove this star along with its preceding character. So our string becomes ER along with 2 stars. Again we'll find the index of the star. We'll remove it along with its preceding character, which is R here. So finally we'll get E and star. And finally we'll check the index of the star in this given string, that is present at index I, we'll remove the star along with its preceding character. So finally we'll get an empty string. So in this given example, we'll return an empty string. So this was the brute force approach where we are finding the index of the first star by iterating from the start, and then we'll remove it along with its preceding character. So the time complexity of this approach would be O of n square in worst case. For example, a string which is full of stars will take O of n time complexity in finding it and O of n time to remove it. So totally will take O of n square time complexity in worst case. And finally, the space complexity would be O of 1 since we modified the string in place. So let's quickly code this approach and let's submit. So this is the code for the brute force approach we have discussed. So here I have used a while loop which will check until or unless the string contains stars or not using the string.find function, which is an inbuilt function present in C++. While there are stars in the string, we'll perform these two operations. So first operation would be to find the occurrence of star, that is find the first occurrence of star, and then finally we'll remove the closest left character, that is the preceding character of the star and the star itself. So we'll perform these two operations until or unless there are stars in our string. So if in case the number of stars in the given strings are 0, then finally we'll return our resultant string, that is S. So let's quickly run this code. So again, so let's submit. As you can see, this approach gets accepted, but the time complexity of this approach is highly inefficient for the largest input. So let's quickly optimize it. So in our optimal approach, instead of modifying the string directly, we can use the help of stack, which would efficiently process the characters. So let's see how stack helps in performing these operations. So here again we'll start iterating from the start of the string. So whenever we find a star in a string, we'll try to pop the recent character used in our stack, or else we'll try to push the non-star characters into our stack. So let's quickly dry run this given example. So we'll start iterating from the starting point of the string. So L is a non-star character, so L will be pushed inside our stack. Again E, E, T. And when we reach at this index, which is star, we'll check first whether the stack is empty or not. So if it is not empty, we'll try to pop the recent character, which is the preceding character, to this given star, and we'll move on to the further operations. So since this is a star, we'll pop the character, that is T here. So the stack contains E, E and L. So again we'll move to the next index of this given string. We again found a star character. So again we'll pop the preceding character, that is E, from the stack. So our stack contains E and L. So again we'll insert all the non-star characters, that is C, O and D. So when we reach at this given index, we found a character star here. So we'll again pop the character from the stack, that is D here. So our stack contains O, C, E and L. And again this is a non-star character, we'll push it into our stack. So after our index reaches at the end of the string, or it passes to the size of the string, we'll stop our operation and we'll take all those stack elements into our answer string, that is EOCEL. And finally we'll reverse this string to get our required answer, that is LECOE. So again let's quickly dry run this given example as well, and then we'll move on to the code. So we'll take a stack, we'll push all the non-star characters into the stack, that is E, R, A, S, E. And when we reach at this particular index I, we found a star character, then we'll pop the topmost character from the stack, that is E. So our stack contains S, A, R, E. So we'll move on to the next index. We again found a star character, we'll pop the topmost character from the stack. Our stack contains A, R, E. And again we found a star character, so we'll again pop the topmost character from the stack. Then our stack contains R and E. And again we found a character, that is star, so we'll remove the topmost character from the stack, and our stack contains a single character E. So again we found a star character, so we'll remove the topmost character, that is E, from the stack. So our stack contains nothing here. So we reach at the end of the string, so we'll stop our operation and we'll take the answer variable and store the characters which are present in a stack. So here, since stack contains nothing, so our answer variable would be an empty string and will return this empty string. So this was a quick dry run of our optimal approach on both the example 1 and example 2. So the time complexity of this approach would be O of n, as we are iterating over string only once, and space complexity here would be O of n, as we are storing all the characters into our stack. So this is much efficient than our brute force approach where it takes O of n square time complexity. So let's quickly code this approach and let's submit. So here's the code for our optimal approach where we are going to use the help of stack to store the characters and process the operations efficiently. So here I have taken a stack of char data type. I have iterated over a string s. So if we encounter a star character, we'll check whether the stack is empty or not. So if it is not empty, we'll pop the recent character, that is the preceding character, which is at the top of the stack. Or else we'll just directly push the normal characters into our stack. So after pushing and removing all the operations until or unless the stars are completed, we'll take a result variable which would be initially empty. We'll iterate over our stack until or unless the stack becomes empty. We'll pop all the top characters from the stack and we'll store it in our result string, and finally we'll return our result string. So let's quickly run this code. It's working, so let's submit. So here you can see the stack based approach mostly passed all the test cases, but it still gave memory limit exceeded error because stack data structures requires extra memory, potentially doubling the space usage. So when generally the input is close to 10 power 5, that is from the given example here, test cases string s, using a stack can exceed memory limit. So for this given string input which is greater than 10 power 5, the stack based approach gives us memory limit exceeded. So we can further optimize this approach, a better approach, that is we can use string as a stack itself. So instead of using a stack, we'll use a string as a dynamic array. We'll use these two functions, that is pushback and popback, which are the functions of a string, which generally work like a stack but with better memory efficiency. So let's quickly optimize this. Let's quickly modify this code and let's again submit it. So here's the modified code where we'll use two functions, that is popback and pushback, which generally works as a stack operations but with better memory efficiency. So here the time complexity is still O of n and space complexity is still O of n but with memory efficiency. So let's quickly run this code. It's working, so let's submit. So as you can see, gives us a successful submission. So let's quickly analyze our time complexity and space complexity of all the approaches we have discussed. So we started with our brute force approach, which generally took O of n square time complexity and O of 1 space complexity. Then we have optimized it using stack, which took O of n time complexity and O of n space complexity. And finally we got the most efficient solution, which is string as a stack. Generally took O of n time complexity and O of n space complexity, but with better memory efficiency. So this problem teaches stack-based character processing and also a useful trick in string manipulation. So that's it for today, guys. If you found this video helpful, drop a like, share with your friends and subscribe for more. I'll see you in the next video. Thank you.